So now we're going to consider the case of the single soliton solution. We're going to try and go through the details of trying to recover this actual soliton solution out of this equation. So what we essentially assume, single soliton just means that there's only one sum here. So K is just equal to V e to the minus V1 e to the minus K1x. Okay, we're only got to find V1. And the equation is that we wrote down before, if we only have one term, is really simple. It's minus V1 plus C1 squared e to the minus K1x minus the sum of, whoops, there's no sum here, minus V1 over 2K1 e to the minus 2K1x equals 0. So we can rearrange this equation and we get V1 must be equal to C1 squared e to the minus K1x over 1 plus, okay, I've lost my C1 squared, don't forget that. Got to be super careful here. There's just so many ways to make mistakes. It's an absolute nightmare calculation. C1 squared over 2K1 e to the minus 2K1x. Brilliant. So that's our V1, and then we recover, remember the K of x comma y, t, is given by minus V1 e to the minus K1y. We're not actually interested in that, we're interested in K of x comma t, and that is going to be equal to C1 squared e to the minus 2K1x. We just multiply V by minus K1x. Brilliant. And then we're going to simplify this and we're going to divide by minus 2K1x. It'll become, it's going to make our life simpler when we differentiate here. Divided by e to the minus 2K1 squared K1x. Okay, so we're multiplying by, make sure this make the sign right, it's a plus now, plus C1 squared over 2K1. So that's K. And I've probably written in the wrong spot, so let's just move that up to here. We can see it as well. Alright, and I've lost another minus sign here. It's so easy to do here. That should be a minus, and that should be a minus. Alright, and then we've got to divide by, makes sense to divide by C1 squared as well. It's minus 1 over C1 to the minus 2 K1x plus 1 over 2K1. Now, we haven't said anything about the C's yet, but we know that the C's evolve according to this. The K's don't change as they evolve. Remember, this is a function of time. So the C1s go according to this Schrodinger's equation. They go as C1 of t is C1 of 0 e to the 4K1 cubed t. So this is equal to minus 1 over e to the power of 4, so it's minus 8 K1 cubed t e to the 2K1x plus 1 over 2K1. With, of equals C1 naught to the minus 2. All right. And then there's a little trick here that you wouldn't think of, and it's just to take this thing here, write this thing here is e to the power of alpha minus alpha. Okay, following the note. So this becomes minus 1 over e to the power of something, right? All the power of 2k1x minus 8 k1 cubed t minus alpha plus 1 over 2 k1. Okay, so we're just bearing this constant as a number alpha. So what we've got to do is now we've got to calculate what the u is equal to. We're trying to recover the soliton. So u is u is 2 the x derivative of k at x comma x. So we've got to take the x derivative of this. Alright, charging on. We now differentiate this. I've got to make sure I make this really clear where the denominator is over everything. So this is this expression here below, so I can differentiate that. I'm going to get to the power of minus 1, get a couple of minuses that will cancel. So I'm going to get on the bottom, I'm just going to get that exponential squared. And then I'm going to get the derivative of that, which is equal to going to be 4k1 times e to the power of 2k1x minus 8k1 cubed t minus alpha. Alright, so how the heck is that equal to? Remember, we want to try and get to the soliton solution. So we've got to somehow show this horrendous thing here is equal to sec squared of something. So wasn't that the a sec squared? So what is that equal to? So the secant is 1 over cosh of whatever. Let's call this, I don't know, this number, I don't know what letter we use, alpha, and alpha's already been taken now, let's use the beta. So it's cosh of beta squared. So it's going to be a over e to the power of x plus e to the minus x squared, or the half here, 1/4 of that. So somehow we've got to transform that so it looks like that, something divided by. So what we're going to do, we're going to divide by this number here, and since it's squared underneath here, that when it comes in it's going to lose the 2. So we're going to end up with sort of coming into balance, right? We're going to end up with 4k1 divided by, so this is going to become e to the k1x minus 8 k1 cubed t minus alpha. So, oops, that's here 4, we're halving everything. And then plus 1 over 2k1 times e to the, we're almost here, aren't we? k1x, this is a minus, plus 4k1 cubed t plus alpha over 2. We're almost squared, we're almost at the point, and we've got this 2k1, we want to balance that up. So that's not too tricky to do. Okay, so to balance the 2k1, we just shift it over to here so that we have, we multiply by the square root of 2k1. So we have the square root of 2k1 here, and we have 1 over the square root. And since we've multiplied by that, we've got to pull this out to the front. So it's going to become the square root of 2k1, 1 over the square root of 2k1, which is squared, so we're going to multiply by 2k1 up here. So this is going to become 8k1 squared. A bit of rearrangement. All right, so we're almost at it, right? I did something silly here, right, where I changed my from x to beta. Let's go back to good old beta. So you can sort of see what the answer is here. Beta has to be, this is square root of 2k1 is e to the power of something, right? So this is, we've got to bang this in here, and this is e to the negative of that. So you can see here that this is equal to 8k1 squared set squared of k1x minus 4k1 cubed t minus alpha over 2 plus the log of square root of 2k1. And that is our solitary wave. Brilliant, we've got here. Because this is just a shift. This is x minus x naught. So this is just a shift. So amazingly we have got here. I wasn't sure I was going to be able to make it at some point here. It's so complicated. So this is equal to, you can see here that this is just a number, some constant, which we can call k1 minus k1 x naught. So this is equal to 8k1 cubed sec squared of k1 x minus x naught. It's just where it starts. Minus 4k1 cubed t. And I've sort of run out of space here, but this is the speed, isn't it? This is minus, this is the speed, and this is the height of the solitary wave. So this is exactly the same form, and you can read off the height. We'll come back to this in the next lecture, what we can read off from this, but just believe at this point we've got there.